There are more properties of equality. We're not going to see these as much as the first four, but they are still useful. Reflexive property of equality. That is when a number or variable or expression equals itself. You'll see one equation. Think of reflexive like a reflection. What you see in the mirror is the same thing as yourself. So in an equation such as x equals x, the same thing is on both sides of the equation. Or it could be with a number, like 3 equals 3. The reflexive property is when I have one equation and I see the same thing on both sides. One equation. Symmetric property, you'll see two equations. The equation can flip or reverse. For example, if 3 equals x. You know, sometimes we solve an equation and we see it backwards. Well, we can turn it around. Then that means x equals 3. So it's the same whether it says 3 equals x or x equals 3. That's the symmetric property of equality. Similarly, here's a slightly more complicated example. If 3 times the quantity x plus 2 equals 3x plus 6, then turn that around, 3x plus 6 equals 3 times x plus 2. Notice I just changed places of what was on either side of the equals sign, those flipped places. The transitive property is when you see three equations. It connects two equations into one equation. It connects them, such as if I have two equations, one is 3c plus 2 equals d, and d equals 5c, then I can connect these two equations. Notice how both of the equations have d in it. So I take out the d, almost like the substitution property that we're going to look at next, and I replace it with what it was from the other equation. So 3c plus 2, the d goes away, and the 5c is connected to that first equation. So one equation, two equation, three equations. To make it a little bit simpler, if x equals y and y equals w, then we connect those first two equations. Notice the y that connects them. We take out the y and we connect the x to the w. So then x equals w. That's the transitive property at work. Finally, the substitution property. We replace or plug in something that's equal. For example, if y equals mx plus b, you know, the equation for a line, and I know that m equals 2 and b equals 3, well then I can substitute. So then what does that look like? Well, the m comes out, the 2 goes in its place. The b comes out, the 3 goes in its place. So my final answer is y equals 2x plus 3. That's the substitution property. On a slightly simpler scale, if y equals 5x plus 2 and y equals 8, then I take the 8 that the y equals and put it in where the y is. 8 equals 5x plus 2. So notice I substituted, I replaced what y is for what y equals, that value of 8. Let's look at some examples. If y equals 2x plus 5, find y when x equals 6. Justify each step. Well, find y when x equals 6. So I'm going to take this equation, y equals 2, and instead of the x, I'm going to put the 6. That's called substituting. I'm using the substitution property of equality. Then I can simplify. 2 times 6 is 12, and 12 plus 5 is 17. So y equals 17. What did I do? I simplified. Number 5, solve the equation. Justify each step. So I have an equal sign. Let's see how we can get the x by itself. Notice the x is over here, so I want the minus 5 to go away. I'll add 5 to both sides. That's called the addition property of equality. Once I do that, I can combine like terms. 22 plus 5 is 27. On this side, just 9x. What did I do? Just simplify or combine like terms. Now I want the 9 that's multiplied to go away, so I divide both sides by 9. What's left over? 3 equals x. What did I do when I divided by 9? I used the division property of equality. After I divided to get 3 equals x, I simplify. Now, even though 3 does equal x, it's not really proper to leave your answer this way. It's better and usually seen with the x first. So we turn it around, x equals 3. So what's that called when I flip around the equation? That's the symmetric property of equality. I flipped this to put the x first. Let's go back to revisit situation number 1 now that we've talked about solving equations and the properties of equality. Situation number 1. Yahira, call her y, is 5 inches taller, that would be 5 more than, twice the height of her little brother Xavier, call him x, so twice x. If Yahira is 65 inches tall, how tall is Xavier? So they gave us this equation. I translated it to algebra, and then they said Yahira is 65 inches tall, so y is 65. I can use the substitution property, and in place of the y, I can put the 65. So I'm going to take out the y, and I'm going to put 65 in its place. 65 equals 5 plus 2x. And then we can solve this equation. Here's my equal sign. I'm going to draw a line to recognize the two sides of the equation. I'm trying to get x by itself. So first I'm going to get rid of what is added. So I'm going to subtract 5 from both sides. That's using the subtraction property. Let's show what's left over. 65 minus 5 is 60 equals 2x is left on the right. Now the 2 is multiplied, so I'm trying to make the 2 go away. Divide both sides by 2. 60 divided by 2 is 30. 30 equals x. Using the symmetric property, let's turn that around. X equals 30. But most importantly, this is a word problem. We want to answer the question, how tall is Xavier? Xavier is 30 inches tall. Take a couple minutes to write a short summary. Why do you think it is important to justify an answer? See you in class.